Hi, AP Pre-Calc. It's Jean Adams from Flamingo Math. We're going to look at Lesson 313. This is our first day, 7 examples, talking about trigonometry and polar coordinates today. We're going to define polar coordinates and learn how they're related to rectangular equations. A polar coordinate system is any system that we can plot points in a plane with the point 0 in the center of a circular grid. Here's our circular grid. The pole is at the point O, which is the origin. This is the pole. The polar axis is the horizontal axis ray from the pole to the right, just this piece here. The polar coordinates are theta there. In this example, r is 3, theta is pi over 4. They're the coordinates for point P. R is the directed distance from the origin to P. So from the origin out to the point P, that's our directed distance. And theta is the directed angle that in this case, this would be pi over 4. So 1/4 of a pi. Let's look at the first example here. We want to plot the points with the given polar coordinates. I like to think of these this way. If R is my radius, I want to go 2 units from the pole, 1, 2. So I want to start right here, and pi over 4 is a counterclockwise rotation. So we can think of this as going 2 units to the right, and then we want to go pi over 4 for our angle measurement, and it has to be counterclockwise. So a counterclockwise rotation would be up in this aspect. So we want to go start at 2 and go up to pi over 4. So that's right there, 1/4 of a pi. So we are right there. We're going to name that point P. On B, we want to start at -1. So we're going to go left 1. And we want pi over 3 to be counterclockwise. So counterclockwise in that case is going to be a downward motion, 1/3 of a pi. So 1/3 of a pi would be at this location. This would be point Q. So 1 left, think about it, 1 left and pi over 3 down, because this is the counterclockwise. On part C, we want to label point R, so we're going to go 3 units to the right and negative pi over 6, which is just 1 rotation down. That would be point R right here. So 3 units right and negative pi over 6. We have a clockwise rotation, and in this case, starting from the polar axis, clockwise would lead us in a downward motion. And finally, for part D, we want to go 2 units to the left, 2 units left, and we're going to rotate -7 pi over 6. That's going to be clockwise. Clockwise is upward, so 7 pi over 6 is going to end up right here in quadrant 4. So our point S is located right here, point S. We went 2 units left, and then a negative rotation is clockwise, and clockwise starting from over here, clockwise is up, so we rotated up. Example 2, we want to plot the point to 2 pi over 3, and then we want to find 3 additional polar representations of that point on -2 pi to +2 pi. And we're given this little handy formula here for ways to go about that. So plotting the point first at 2, we're starting 2 units from the pole, that's to the right, and 2 pi over 3 is going to put us right here. So this is point, we'll call this point P. Point P. Well, point P. And first, to get one different representation, we could either add or subtract 2 pi. So 2 pi. If I subtract 2 pi, we're at negative 4 pi over 3. The second way we can do is we can replace the r with the opposite of r and add pi. That would be negative 2, and add pi to 2 pi over 3, we would have 5 pi over 3. And another way we could do that is to change r to the opposite of r and then subtract pi. That would put us at negative 2 and negative pi over 3. So all three of these polar points would end up landing right there at the same spot, point P. Write the rest of the possibilities using those formulas. Well, we would keep the r for this formula. We're going to keep the r and take the angle 2 pi over 3 and add 2 pi n, where n is an integer. And then to use this formula, we want to take the opposite of our r and add theta plus 2n plus 1. So adding pi to that. When n is 0, we would add pi to that plus 2 pi n. And in each one, n has to belong to the set of integers. There's relationships between polar and rectangular coordinates. Those relationships are given here. X is r cosine theta. We've seen that already. Y is r sine theta. And if we have polar coordinates and want to change from rectangular to polar, we would use these formulas. This is the Pythagorean theorem on a unit circle, and this is the angle measurement, which is the rate of change. So let's give those a little bit of practice. We want to find the rectangular coordinates for the points that are given in polar coordinates. Well, we know x is r cosine theta, and we know y is r sine theta, and r is 3, and theta is 5 pi over 6, and the cosine at 5 pi over 6 is negative square root of 3 over 2. So our x value will be negative 3 square roots of 3 divided by 2. And y is r sine theta. So our y coordinate is 3 times the sine of 5 pi over 6. The sine of 5 pi over 6 is a half. So our y coordinate is 3 over 2. So here we have the x and the y coordinates from our given polar coordinate. Point Q, using those same formulas, x is r cosine theta. So x is 2 cosine negative 7 pi over 6. So x is 2, and negative rotation is going to be negative square root of 3 over 2. And then y is 2 times the sine of negative 7 pi over 6. So y is 2 times 1/2. So I'm thinking just a minute here with you. If we start over here and we rotate negative 7 pi over 6, here's 5 pi over 6 negative, so 7 pi over 6 is going to be up there in quadrant 2. And the x is negative, the y, x is negative, y is positive, giving us the x coordinate. So xy is going to be negative square root of 3 and 1 Our terminal angle is in quadrant 2. Let's go the other way now. In example 4, we're going to find two polar coordinates for the points that are given in rectangular coordinates. This is an xy value, and we have two new formulas. Our formula for the radius is the square root of x squared plus y squared. And the formula for the theta is the tangent inverse y over x. So let's think about this. R is 1 squared plus negative 1 squared, the square root of that. So our R value is square root of 2. And our angle is going to be the angle where tangent is negative 1. And using the inverse function, our angle measurement is negative pi over 4. But stop a minute and think about this. Our xy is in quadrant 4. This is our point, 1, negative 1. If we have a circular rotation, how do we get from the polar axis over to here to be at that angle? So that angle is either going to be, we can write it as square root of 2 and negative pi over 4. You can write it as negative radical 2 and 3 pi over 4, because I could come over here at negative 2 and go down 3 pi over 4. Or we could start at positive square root of 2 and, like I said before, go all the way around and end up at 7 pi over 4. But that's 3 different ways to write the polar coordinate for our xy point. For part B, same formula. The radius is the square root of x squared plus y squared under the radical. Square root of 4 is 2. And our angle measurement is where tangent is 0 over 2. So the tangent is 0 at 0. We could write that solution 3 different ways. We can write it as 2, 0. We can write it as negative 2 and around pi, or we can write it as negative 2 and around the other way pi. Does that make sense? If our circular grid, 2, 0 is here, start at negative 2 and go counterclockwise to pi, or start at negative 2 and go clockwise to negative pi. They all 3 put us in the same general, same location as our point 2, 0. Then example 5. Here's some helpful tips for converting from rectangular to polar form. And we can use those. For example 5, we want to express the given equation in polar form. If y equals r squared, our y value is y is r sine theta. And our x value is r cosine theta squared. If we have the left side, r sine theta is 1/2 r squared cosine squared, then we can take an r out of each term. So r sine theta, multiply this side by 2. 2r sine theta is r squared cosine squared. We could divide out by an r and end up with 2 sine theta is r squared, is r, because we're dividing by 1r to get rid of one r on the left and one r on the right, gives us cosine squared theta. Solve for r, we have 2 sine theta over cosine squared theta. I'm going to write it this way because sine over cosine is tangent. So we have 2 secant, which is this cosine on the bottom, and tangent, which is the sine over the cosine. So I'm going to erase this and put the final answer all neatly together here. R is 2 secant theta tangent theta. Whew, let's try the next side. And we want to make a note maybe that r is not 0 since we divided by a variable. Okay, 4x squared, so 4x is r cosine theta squared. Y is r sine theta equals 1. 4r squared cosine squared theta times r sine theta equals 1. What do we have? 4r cubed sine theta cosine squared theta equals 1. We could stop there, but we also know that sine of 2 theta is 2 sine theta cosine theta, and then we could rewrite 2r cubed times 2 sine theta cosine theta cosine theta, and here's 2 sine theta cosine theta is sine 2 theta. I'm going to rewrite that so we can have 2r cubed sine 2 theta cosine theta. Okay, so we got 2r cubed sine of 2 theta times cosine of theta equals 1. And then I got one more thing I think we could do. If we divided by sine and cosine, we could also rewrite that to be 2r cubed is 1 over sine 2 theta, that's cosecant 2 theta, and 1 divided by cosine, that's secant theta. All different ways we could represent that. That one is a little tricky. Example 6, we want to convert each equation to rectangular form and identify the type of graph and support our answer with a polar graphing utility. If r is 4, we know this is a circle, and the center is at the origin. And in rectangular form, x squared plus y squared equals r squared. So the equation would be x squared plus y squared equals 4 squared, which means our radius is 4, the diameter is 8, and our equation is x squared plus y squared is 16. Here, theta is 2 pi over 3. If you think about that from a graphic point of view, this is your x and this is your terminal ray, and our theta is 2 pi over 3. So what do we know? We know the slope is the change in y divided by the change in x, and that's radical 3 over 2 divided by negative 1/2, because our coordinates are negative 1/2 and square root of 3 over 2. If we divide those, that gives us the slope is the square root of 3 negative. That line passes through the origin. It has a slope of negative radical 3. So if we know that, we can write a y equals mx plus b equation. Because we pass through the origin, we have a slope, and we have y equals negative radical 3 times x. And then part C, still converting each equation. Here we have r is 2 cosecant. So r is 2 times 1 over sine, using a trig identity. R is 2 divided by sine. So r sine theta equals 2. R sine theta is y equals 2. This is a horizontal line. And then lastly, a little algebra trick here. We don't have anything to replace this right side. So let's just have a little r times the left and a little r times the right. So then we have r squared is 6r cosine theta. R squared is x squared plus y squared. And r cosine theta is x. If we move the x to the left, we can complete the square. And completing the square, half of 6 is 3. 3 squared is 9. I can add 9 to the left, and I can add 9 to the right. So we're keeping the equation balanced. This left factors to be x minus 3 squared plus y squared equals 9. We know that to be a circle from geometry. So we have a circle. This is a circle. Well, I want to write a circle. R is 3. We got that from the square root of 9. And the center of our circle is at the ordered pair 3, 0. We got the 0 from y squared, doesn't have a term. And then our last example for this set of notes, we want to convert this circle to polar form. First thing we'll do is expand x minus 3 squared, x squared minus 6x plus 9. Expand y squared minus 4y plus 4 equals 13. 9 plus 4 is 13. There's 13 on the right side. We have x squared minus 6x plus y squared minus 4y equals 0. Let's put the x squared and the y squared together because we know that represents r squared. And then minus 6x and minus 4y. Then we have minus 6 and x is r cosine theta. And minus 4 and y is r sine theta. That equals 0. We can factor out an r from all the terms. R times r minus 6 cosine theta minus 4 sine theta is 0. R can't be 0 because that's only a point. And we have left over r minus 6 cosine theta minus 4 sine theta is 0. So r is 6 cosine theta plus 4 sine theta. I would recommend you put your calculator into polar form and check that on your calculator to be sure that you have a picture that we know is a circle whose center is located at 3, 2. We got that back here, 3, 2. And we have a radius of radical 13. So 3, 2 is the center of our circle, and a radius of radical 13. You should get this picture with this equation or this equation. That's it for the first day. We'll finish up tomorrow.